Kia ora hui mai koutou. Nau mai haere mai. Welcome back. Welcome to the afternoon session where we're starting with a keynote, then moving on into streams and finishing with a panel discussion and rounding up at about 4:30. So it is my honour and privilege to welcome our keynote, our third keynote of the day. Beside me, looking very tall beside me, is Simon Urbanek. Simon Urbanek survived 15 years working for AT&T in New York and New Jersey, where he was doing large-scale data manipulation, modelling, management and analysis. He then came to Auckland to escape the high housing prices in New York. Yeah, good luck with that, bro. And is now based at the University of Auckland, where he's a senior lecturer. He's also one of the R Core, one of the 20 R Core people who manage R across the planet. We're lucky enough to have 3 such people at the University of Auckland Stats Department. And Simon is the newest one. Over to you, Simon.
Thank you very much. So thank you very much, Andrew. So today I wanted to talk about some of my experience at AT&T, where we've been analyzing big data sets, and while we were doing that, we were building tools that would help us to do that in sort of a easier fashion. And as we were doing it, we were actually developing everything in open source. So we're trying to really live by the motto that Andrew was saying. We should really give back everything we can, when we can, just put it in open source so other people can use it. So what I want to talk a little bit about the ideas that made us do it, actually show the system, and talk also in the context of the conference here, sort of what lessons did we learn with respect to data and things that had to do with the design. So first, the motivation. Really, the motivation for the entire project was that we were doing data science all the time, but it was usually, we had to find a machine somewhere, get the data there, run some scripts, answer the results, produce some results, give it to someone. And then 6 months later, someone comes in, hey, I've heard you did this cool thing. Could you do something similar? And then, of course, I don't remember which machine was it on, where is the code, does it even run, does the version exist, and all that. So we decided to try to think about what would it make much easier for us to reuse code, to collaborate, to make sure that other people can leverage what you've been doing, and at the same time make it all scalable, because the scale of data sets that we've been working on has been in hundreds of terabytes of data points, of data in general. So we tried to build something like that. So the motivation was really just the classic data science process or pipeline. So we have our import, cleaning, transformation, so different tools used for that. There's a lot of different things. Visualization modeling, very close to our heart, because of course any data you see, it's going to be messy, so you need to visualize, then you start thinking about modeling. And at the end of it, you just communicated that to some other people, which means often using things like web pages, or maybe even interactive if you can, and so on. But one thing that's sort of missing in this sort of view that's been often shared is oftentimes it actually involves a lot of different people, because you may not necessarily be or in our case, we were not necessarily always the experts in the field. We had other people involved, the people actually communicating, maybe different people, and so on. So we really wanted to make sure that we can leverage several people working on things, and then also maybe borrowing pieces that have been done for one data set to a different data set, or one project to another project. So that's where the collaboration and reuse comes into play. So we really wanted to make sure that we can reuse things and that things become discoverable. So if someone did some work, I want to know about it. I want to be able to find it, and then also just be able to leverage it. So in the context of this conference, I figured I'll actually add one more aspect to it, which is true as well, which is in even more complex settings, such as we have here, where you can have different agencies trying to get data from different agencies with different restrictions, with different conditions on the data, and so on. That's very often the case as well. So we had many different business units, from TV to network to advertising, all kinds of with very different constraints on the data set. So that's very often the case as well. So you wanted something that actually allows us to combine these things with these conditions still in place. So the idea was to develop something which we called at the time R Cloud, because R was the first language that we supported, and we only later on moved to other languages. But the whole idea was essentially take the analytic process and move it to the cloud conceptually. So not necessarily meaning it's somewhere you don't have access to. It's meant more like a concept where you don't actually care where exactly it's living. You have control over it, but you can connect from your home machine, you can connect from your laptop, from your iPad, from your desktop. It doesn't matter where you are. You want to be able to do your analyses and access them. So as a user, you don't care. So both the consumption and development is in the cloud, so which means you are performing the analyses as if you didn't know where it is. But also, if you share something with someone, they shouldn't care. They shouldn't need to download anything. So at the same time, that solves the scalability issue, because that means if you have the resources, you can just put big machines or VMs or big clusters in your organization, and then you can allow access to people that should have access to it, and they can just access the system. And we've also made it such that everything you do is version controlled. So any code, anything you do essentially goes into Git. So everything is traceable, and you can find out what anyone's doing. And finally, it's all web-based, which I guess today is not such a big surprise, but when we started, which was a couple of years ago, something like 5-6 years ago, that was not always the case. So the idea was that way we can leverage it from any machines or any locations. And finally, the whole idea was that it's all about sharing and collaboration. So we can share code and the results. So it's not just about the results. Sometimes people like to share, results as files and so on. But we wanted to also share the actual analysis so that you can replicate it and run it. So the whole concept is about discoverability, search, running, commenting, forking, modification, and so on. So I want to give a quick demo of R Cloud, just show a little pieces. I don't have too much time, so I won't go into details, but just to have an idea. So essentially, at the bottom line, you just go to a website. So all you need is really just one single open port. So usually it's HTTPS secured. That's all you need to essentially get access to the system. And then once you're in, you can log in. You can do silly things. It does support things like graphics. So here I'm just using R. And it works sort of in the now already familiar notion of notebooks where you're just continuing to work, and it just records what you've been doing. You can reorder things, you can delete things. There's a lot of support for that. And that's how you can work. And everything you do, as I was saying, is version controlled. So you can actually look here and you can see when did you do what in time. You can go back to any version. You can revert to it. You can look at all that. Then I said one of the main points was that we have shareability, so that you can actually share things with other people. So what we did is we have this button here, it's shareable link, and all it does is essentially gives access to the code, which you can just have in this view mode, which shows you the results that are actually being computed. So this is not stored, and I'll go into why that we thought that was a better idea. So you can send it to someone, they can look at what you've been doing, and if they want to, they can actually go back to your code, and they can fork it and modify it and make it their own, and make their own version. And so for example, if you send someone a result of an analysis, you can just go into, and he can then go into the edit mode and look at things like residuals or compare with other data sets and so on. So you can continue working where the other person left off. And then vice versa, if I see that you did that, I can look at what are the changes compared to what I did. So everything is based on version controls again. So essentially you can do diffs and merges and things like that. Other thing is that, let's say discoverability is one thing. So we said we want to be able to search for things. So right now I'm just going to search for a data set in this case, and I'll see, oh, okay, so there is some result involving this data set. So I can just load the notebook, I can just run it, and I can look at it. And I was actually looking for another one. Well, this one has regular graphics, and then at the bottom here you actually have some interactive graphics. I mean, fairly rudimentary here, but you can, because everything is web-based, you can embed JavaScript and you can use JavaScript visualizations. Again, our people are probably not, very familiar with this because you can use HTML widgets, you can use Shiny and things like that. In fact, we have direct Shiny support in the system, so you can just use Shiny applications. So for example, here, and this is just regular Shiny code, we just wrap it in saying you want to show it in our cloud, and then the result is the shareable link, instead of just using the output, is actually running the Shiny application. So you can run Shiny applications. And actually, it's not using our studio server. It's using instead our cloud. And finally, one thing I should mention is that we do support multiple languages. So right in this installation that I'm running, we have Markdown. So there was some talks this morning about how Markdown is useful to have annotations and code. And also we support Shell, Python. In fact, any Jupyter kernel can be used in our cloud because we have a binding that allows you to just run Jupyter kernels from our cloud. So I think that's it for now. Let's go back to then, all right, so this is all this hopefully cool stuff. And we've been actually using this for our own internal purposes. So we've been running our analyses and sharing actively, between the people that are working on projects and so on. So how does it actually work? So as I said earlier, we do have the user that just needs a browser. That's all you really need. So with the browser, you just connect to potentially one of many our cloud servers. So you can load balance the whole thing. And that server will then connect to the resource store, which is essentially where all the notebooks are stored. And they are stored in Git repositories. So they are literally just Git repositories. So you could clone them, you could deal with them in any regular way, just as you would with Git repositories. And then we have a small metadata server that's essentially just caching information about things like making the search possible and so on. And finally, from your R session server, you can essentially connect to any computing clusters that could be done, like Hadoop, Hive, Spark, and so on. So that's how you can scale beyond just the users. So the scalability in the centerpiece here is about having multiple people potentially connecting to different machines. Maybe you have some with GPU resources, some without, and so on. And the right-hand side is then the big computing clusters that you can just access from that. The way it works is we've been really trying to make sure that the whole thing is secure. So it's not something, our first prototypes just allowed arbitrary code execution by sending commands to the server and saying, okay, do this. And the server says, okay, sure, we'll do. So that is not very secure because then anyone can send anything, right? So we made sure that the servers is really just responding to, in the beginning, to a simple command that says, I want to authenticate, and it cannot do anything else. It won't allow you to do anything. And it all works with just details here about different processes involved here. And I won't go into these details. But once you have authenticated, then the server can supply information, what are you allowed to do. So that way, you're guaranteed that you cannot just circumvent the authentication by doing something that you're not allowed to. So there is never arbitrary evaluation. And that's important if you start thinking about trusted environments. If you want to say, I want to know what people are actually running here. If I have some constraints on that I want to impose on the use because of, let's say, the environment that, the data environment that requires this, then we want to be able to implement that. As I was saying, all the notebooks are just stored in our version control. We actually support multiple backends. Originally, when we started, we were just using GitHub. But then we get into some issues if you want to deploy it internally and so on. So we just wrote our own backend, and you can also run it just on local Git repository. So You can actually run it just on a laptop as a standalone installation, and then you can just use Git repositories on your disk, and that's it. The deployment is very flexible. Again, this was a very conscious decision because we wanted to support things from enterprise-wide installations to just a single Docker container. So you can actually deploy this in a single Docker container. So you don't even need a dedicated machine, just a Docker will do. You can also just run it on your local machine, such as a laptop, or you can have a full-blown enterprise installation with many servers and authentication and multiple users and all that. So it's very flexible with respect to how you want to deploy it. As I was mentioning earlier, it does support visualization because there is a direct binding to JavaScript. Again, I don't have enough time to actually go into technical details here, but it essentially allows you to run arbitrary JavaScript functions from R and arbitrary R functions from JavaScript, which then can bind to other languages as well. So it's very powerful that way, and that's how we are able to implement different visualizations, including Shiny, RCAP, and others. So back to our diagram about the data. So far I've been talking essentially about a platform which is, as we call it sometimes, social coding platform. So it allows multiple people to just perform analyses and share the code, search for each other's code, and run each other's code. But then there is also this aspect of how do you actually deal with multiple data sources and how do you combine all that. So the idea really is that we're leveraging the flexibility of R here so that, for example, we have modular bindings to many different data sources. So we actually wrote special packages for Hadoop so that we can run Hadoop jobs at very high scale. You can use HDFS, Hive, Spark, and so on. Obviously, you could do that from the Python side if you want to, because we support Python, or you can do it from the R side. You have all the databases. And the key point that I want to make here, that even though it's sort of not unique to the design of the system, is that you have control over the API or tools that the users will have at their disposal, which means you can handle things like data access and providing sort of higher level tools that allow people to do these things. So, and we did similar things where we essentially defined special functions where we said, okay, if you want to access certain data sets, this is the functions you will use instead of sort of manually loading files or anything like that. And that allows us to keep that in sync with the requirements of, let's say, the data or even technical issues with combining data sets and so on. So that's one thing. Second thing is you don't need to actually embed anything in the code because the platform allows you to encrypt things and have your own keys, your own content. So that means you don't need to include that in your code. You can just have that stored so that it's not directly accessible. It's only accessible when the code is executed, but not to the user to sort of pull it out. And so it has built-in support for encryption. And again, as I was saying, because everything goes through Git, that means anything that anyone does is logged because there is a record in the version control system that cannot be erased. And you cannot execute code without first committing it to the repository. So again, gives sort of guarantees, even though it doesn't necessarily prevent abuse per se, it allows at least tracking. If you had someone abusing something, then you would actually know at least who it was. And also, the last point that I also won't go into full details into is that although we designed the system originally essentially for us data scientists just to do our work, then later on the production people came and said, well, it's all nice, but I actually want, if we wanted to deploy this, we don't want to rewrite your code, we just want to run it in production. And we realized, well, this is now really easy because we already know under which conditions our code runs. So we can just simply replicate that and move it to production. And then that process, we know that process will work. So we actually enabled Dockerization where you can simply click on a notebook and it will just create a Docker container that can run that process. And you can just put it in production as it is. Now, I'm not saying that's always the best thing to do, but it's definitely something that you can do. So that way you go from just experimentation, where you would be just looking at data set, doing EDA, and then just understanding it, to a point where you can actually define the rules, how to, let's say, wrangle a data set, and then you can give that just to the production team, and if they so choose, they can just say, all right, let's just turn it into a Docker container and run it somewhere. So, there's a lot of flexibility in that. So, in short, so I was trying to show that it's beneficial to have a collaborative analytics environment. So obviously, if you just single person on a single laptop, that may not be the best idea, but the moment you start interacting with other people, and especially if you want other people to use your code, it's very beneficial, because once it is in the system, anyone can access it, anyone can run it, anyone can look at it. And so that enables sharing, reproducibility, because we know that the code run for you, so it will run for someone else. Modular data access. So if someone does not have access to the data that you were using in your analysis, then it will fail. And that's intentional, because we don't want to leak inadvertently results that you didn't have access to. And that's the reason why, when I was saying in the beginning, that we do not actually implicitly cache results and store them, because we want that to be a decision of the user or the analyst, because we want to. It would be close to impossible to find out if someone else has access to data where you combine 3 different data sources, because pretty much the only one who can decide that is then probably you, if you created it, because you had access to all the 3. So you will tell us, what are the requirements. So that's why I was saying, that's the one thing where things wouldn't be reproducible if you don't have access to the data. So it's also browser-based, which means, it's ubiquitously available, essentially. And it's easy to control access, because it's just one port that you can monitor. And it is extensible. We have made a lot of things modular. So, for example, the support for different languages is just a small API, so you could define new languages. And that's, in fact, how we did the Jupyter kernel support. It's essentially just one of these modules that just, as a language, says, well, it's Jupyter kernel. So that's how it works. And supports interactive web graphics, and it's all open source. So it's available under MIT license, so most, really with no strings attached. And so people can try it out. So here are just, my collaborators that we started this with Carlos as the original prototype, and then Gordon Woodhull came and essentially wrote all the graphical user interface, so that all that cool stuff is his work. And we do have a global site, which is right now running on AWS in the US, which is rcloud.social. And then I'm also running a site in Oakland, because it's much better to just stay local. And that's the rcloud.nz site. So it's not as polished website or anything like that. But it works. So again, all open source. And thank you very much for your attention.
So there's one solution to open data, in terms of open data collaboration, sharing and sharing code. Has anybody got a quick question for Simon, given that he will be down again in Wellington? What date did we decide on?
26 or something like that?
Yeah, 26. Like yeah, doing a seminar at Stats New Zealand, but we do have some time for some questions now.
What's the relation to the RStudio interface? If I want to use RStudio as an IDE with this system, will it work?
So we were focusing on the collaboration aspect, and we kind of cover a lot of the ground that RStudio covers. We were actually in talks with RStudio for years, almost from the beginning when we started the project, but sort of it never really, we were offering even that we will give them the collaboration code and they can build it in, but they just never happened. So it's just 2 separate projects, and we've been trying to, so our paradigm is a little, so because it's more focused on collaboration, it's a lot cleaner. Like the notebook interface in RStudio is kind of an add-on that doesn't really work all that well. But RStudio is really good for like single analysts with all the scripts and project management and so on. So I would say, I would see them as sort of 2 separate ways to use R. Like one is for local work if you're working on your own machine, and the other one is more the collaborative aspect, which tries to streamline the sort of the development and the collaboration aspect of it. I mean, there's still maybe some hope that at some point that can be merged, but you know, well, we are always open, but so far it hasn't happened. Okay, so the question was essentially, if someone picks up someone else's work, is there any way of a QA or some kind of checking, knowing what is correct? So there is not. I mean, the only thing that we do is that we know if something is running or not, right? So we can replicate. We know that by the virtue of this being in the same system, that if you run it or I run it, the only difference should really be with, as I was saying, with the data access. But it doesn't. I mean, there is no automatic checking or anything like that. And the thing is, though, if you can like both users can compare. So I can see what I changed, and you can see what I changed. You know, I can see what you changed, and you can see what I changed. So that way you can compare. You can run both versions, and you could merge them if you wanted to like pick things that you thought, oh, you fixed my issues. Originally, we actually also added a feature which was commenting on notebooks, so you could actually send someone a note saying like, oh, by the way, do you know that this analysis is actually wrong? But to be honest, no one actually used it. So I think it may be still there, but it just hasn't been used. One thing we did add that was kind of an attempt at the collaboration aspect of it was this concept of starring. So if you like someone else's notebook, so we have this category, and I didn't go into that whatsoever, but if you see someone else's notebook and you tried it, you can star it, sort of just like you can start repositories on GitHub. So you could have a measure of sort of how popular is a particular notebook, and that also you can use that in search to create conditions saying I only want to know, or I want to sort them by stars and things like that. So we've been trying to something as a proxy to it, but it's not something would automatically figure out if something's working or not. But it's a very good question, because what has happened over time is if you have much older notebooks, chances are that something broke, either in a data pipeline. So it would be nice to have like an automated check if this still works. But yeah, we haven't added that.
Right, we've now hit the time for the afternoon session. So thank you very much, Simon. As I said, Simon will be back down in Wellington doing a seminar at Stats New Zealand, so look out for that. In the meantime, we're heading back into our streams. So if you're in Stream A, stick around, you're in the right room already. Stream B is in Rangimarie 2, and Stream C, I'll see you in Stream B is in Rangimarie 1, and Stream C is in Rangimarie 2, and I'll see you in there.